Welcome back to Building Games on AWS, where in this series we'll discuss various topics as it applies to game development. Today we'll focus on DDoS resiliency, and here with us today is David Height, a senior game tech solutions architect as well as an edge specialist.
Hey everyone. Yeah, my name's David. I'm solutions architect. I'm with AWS for 3.5 years, and before that I was working in ad tech. Since I'm working in AWS, I built myself up also an expertise on DDoS attacks and how to make web applications more resilient. And it really comes together well with my passion for gaming. And since I also joined the game tech organization in AWS 1.5 years ago, this is now my favorite topic, where I always learn something new every day, and where I like to share my knowledge, because the more secure our customers are, the happier I am, and they are as well.
So my first question is, what exactly is DDoS? I mean, I know what the acronym stands for, but that seems to just be the scratching the surface.
Yeah, that's right. And maybe let's remove the first letter for now and just talk about DOS, which is the denial of service. And it's quite a common attack. It's been around for a long time. And denial of service basically means an attacker makes the target, which could be, maybe a classical web server or something like that, so busy that it cannot respond to its original requests, and therefore making it inoperable to serve what its purpose is actually. And now when we take this first D again to that word and make it DDoS, then we speak about distributed denial of service attack. The internet consists of a lot of devices, so it's not anymore our computers or servers. It's mobile phones, cameras, smart TVs, our internet routers. Basically, all of this participates in the internet, and unfortunately, a lot of these devices are also compromised in some way or the other. And attackers can leverage these networks of compromised devices to run an attack that is then distributed. So it comes from all over the world directly at one target. And this is just a sheer mass of requests that are super hard to handle for any resource, basically.
But is it like when a bunch of shoppers just waiting in line in front of a store, but not being able to get in?
More or less. I think you have to differentiate here a bit. It could also be that they are not shoppers at all. So imagine they're running a store, and someone told a bunch of people everything is free today. And they would all run for your store and try to get in, but with no intention to buy anything. So with no intention to actually do what your business usually would do. And these people are blocking the door, obviously, because it's a lot of them. And then the people that actually want to buy, they can't get in. This would be what we call like an infrastructure DDoS or volumetric attack. The problem here is the store owner. They have to evaluate for every person that enters, is it actually a person that wants to buy, or is it the person that's here for the free stuff, which we don't serve?
Yeah, so David, you mentioned there are different types of DDoS attacks. Could you tell us a little bit more?
Yeah, that's right. There are attacks that are targeted for the infrastructure. So when we look at the OSI model of the internet and networks, basically on layer 3 and layer 4, this is where the lower level protocols happen, like TCP, UDP, ICMP. And these protocols are also already by protocol vulnerable to some kind of attacks. It's not that they would be insecure, it's more like they have to stick to the protocol in order to make sure that it's a good data exchange, and this can be abused. This is what we call infrastructure attack, because it's not really targeting an application. It's rather targeting the infrastructure. It's targeting the network stack of a resource and trying to exhaust this. And if you talk about a big DDoS attack that has maybe a couple of terabits in volume, which is very rare, but it happens. You read that now and then. Then we talk about attacks that are so big that they just exhaust the bandwidth of a resource. So your server might be powered up and capable of handling anything, but if the network bandwidth is not enough, that would also just make it unreachable. And the second type of attack is then application attacks. So let's imagine a bulletin board, for instance, where you have a web server and a relational database. Maybe you have a load balancer in front of this, and it's an app that's working quite well. A lot of users can go there and ask questions, read answers, and so on. But when you look at the architecture and how this works in detail, as an attacker, I would probably assume, well, if I search for a lot of terms, a text search is more cost intensive than, for example, looking up an ID that is indexed in the database. So me as an attacker, I would probably say, if I want to bring down a bulletin board, I would just forge a lot of requests that contain a lot of randomized terms that is fired against the search endpoint of the bulletin board. And this would make it probably very, very busy, unless it's using a search engine in the background, like Amazon OpenSearch, for instance.
Okay, so now you kind of gave us a clue about what types of attacks are effective against bulletin boards. I would ask you, what type of attacks are effective against game servers?
Well, in its nature, the attack is the same. So the attacker basically has to do some research and understand how does your application work. And this can be, of course, a bulletin board, but it can also be a game. And the more I do engineering, reverse engineering, trying to figure out how that works, the more I get an idea of what I could actually do to hit this. Here we talk about probably game backends, and you know, games can have different types of backends, and not all attackers are in fact considering themselves as criminals. You could have persons that just want to go on top of the leaderboard, or you might want to have persons that want to get something that they should buy in-game. Maybe they want to get the item for free and then try to circumvent your systems to some extent. So I think attackers for game workloads have a different intention than regular attackers. But of course, for us as business owners of game workloads, it doesn't really matter. It hurts the business, and therefore we consider this as attacker. Yeah.
So earlier you mentioned some motivation behind why these bad actors, instigate a DDoS attack against the game servers. Could you talk a little bit more about that?
Mm-hmm. Yeah, sure. When we speak about game servers, we usually think about multiplayer games. So where like people are playing together or against each other in real time. And this is a different scenario from what we know, from web applications, where we can easily scale out or scale up. Like for instance, if a web application is slow, I can add another node to the load balancer. I can scale a database, and basically I can respond to a DDoS attack with a standard application that is scalable by just scaling. And this is in fact what the cloud allows you to do. When we talk about game servers that are made for multiplayer real-time play, then it's usually really just a server or an instance, speaking in AWS terms. And then it's much harder because all the state is stored on this instance. And I had one customer, for example, they were running an RPG game, and attackers attacked this game by just sending a lot of UDP packets to the open port, because the game worked on UDP as most multiplayer games do actually. So you cannot really block the UDP port. So you have to some extent accept all the traffic that gets in at that specific port. And basically, a lot of attacks came to the specific port and slowed down the server massively. Now, what happens? What happens when you slow down a multiplayer game servers? Well, the interaction with the players doesn't work as usual. Players will probably experience some kind of lag, or gameplay will not act as they used to be. There will be lag in the actions that they do, maybe not maybe resulting in a higher ping, or you know what I'm talking about. But if we talk about the game mechanics and the NPCs, so everything that happens on the server, this might of course also lag, but not as laggy as human reflexes, right? So for example, if you would fight an NPC in that scenario where the server is under attack, the NPC would clearly win because it has the better reaction time, as it doesn't experience lag or can handle lag quite easily. So what these attackers did in that particular case, they just went to a safe zone, like a non-combat zone, or a safe spot in the game, and just ran the attack, waited until it was over, and then went out and collected all the loot that was dropped from the heroes that were slain in that world, because they couldn't defend themselves. Pretty bad for the customer, for my customer, right?
Yeah, I've never would even thought of that. Certainly elevate cheating to a whole new level.
Exactly. Yeah. And as I said earlier, cheaters do not consider themselves as criminals. But if we look at it from a high level, it is an attack. Full stop.